So we're going to give people a few more minutes to join us. And I'm going to have to put something in the chat window, a little bit of legalese, and then we'll get started. So we'll maybe start in 1 more minute. All right, hi everybody. Welcome to Notre Dame. My name is Dan Gezelter. I'm the Associate Dean for Undergraduate Studies in the College of Science. And I'm going to put a little bit of sort of legalese in the chat window that we have to put there. And I also want to introduce the Dean of the College of Science, Professor Mike Hildreth. He's a physicist who has just stepped into the Dean role as of January 1st. So Mike, you want to introduce yourself a little bit? You got to unmute.
Hi, welcome everyone, and we're really happy that you could join us this evening. So as Dan just said, I'm the Interim Dean of the College of Science. I just started in this role January 1st, but I was Associate Dean for Research and Graduate Studies for the past 4 years, so I've spent quite a bit of time here in the Dean's office, although now I'm in the actual Dean's office. So I'm going to give you a little bit of a high-level overview of the college this evening, and then pass the baton back to Dan, and he can talk about the more specifics of the undergraduate program. Okay, so we always like to start off with a historical view, maybe a little bit of the College of Science. And so Dan, if you could go to the first slide there. Yes, so now I bet not many of you realize that Newt Rockne was actually a chemistry major and was offered a position as a chemistry graduate assistant when he graduated. He sort of took that on the condition that he could help the current football coach. So science, in terms of the partnership with other aspects of the university, has a long history here at Notre Dame, as does the College of Science itself. It was founded shortly after the university itself. I think 1865 was the founding date. And there's a long history of contributions to the scientific world, if you will. Father Newland, whose name is on one of the main science buildings here, was a chemist and discovered synthetic rubber, the basis of neoprene. During the 1940s, we had the first electron accelerator in the United States that was used to study nuclear disintegrations. Our nuclear lab is actually one of the strengths of the College of Science. That tradition still continues. And another tradition we have is a long history of working on vector biology, trying to understand how mosquitoes transmit disease and the diseases that they transmit. And then in the center, our very own beloved Father Hesburgh, former president of Notre Dame, received the Public Welfare Medal from the National Academy of Sciences. It's the highest medal given for the National Academy, and this is given for his deep understanding of the importance of science and the advocacy that he had for using science to solve the world's problems. So this is our history, and so, but we don't like to rest on those laurels. So we like to tell you a little bit about where the college is today and why you may be interested in studying in it. So Dan, go ahead. So it's a modern College of Science. It has extensive research capabilities, brand new facilities, and a lot of very accomplished faculty. And so I'm going to give you a sort of high-level overview of this and introduce you to some of the aspects of the college. So go ahead, next slide. So on the map, there are 5 departments. We're sort of centrally located on campus, although there are several other buildings. There's the Harper Cancer Research Center, and we actually partner with the IU School of Medicine, which are both sort of south of the stadium. But so we're very close to the dome for the most part. There are 5 departments: Applied and Computational Mathematics and Statistics, which we call ACMS because that's way too long, Mathematics, Physics, Chemistry and Biochemistry, Biological Sciences, and then Chemistry and Biochemistry is actually split across maybe 3 buildings. So there's another new research building up into the right called McCourtney Hall. And then there's Jordan Hall down on the right, which I'll talk about in a second. So there are 5 departments. We have between teaching and research faculty, almost 200 of them. About 170 of those are tenured teaching faculty. Most of those people, most of the 200 have independent research programs. And per graduating class, there are about 400 majors in the college every year. So the sort of faculty to student ratio is pretty good for this college. There's a lot of opportunity for individual attention, small classes, and as I'll talk about, research in the research labs. So please go ahead, Dean. So here's a picture of the observatory on top of Jordan Hall with Touchdown Jesus in the background. So we're kind of right there in the middle of campus. So the highlights of the college, if I were to call them out, we think that we present an outstanding education for our undergraduates. We have excellent faculty. We have extensive research opportunities for undergraduates, both on campus and around the world. And I think it's fair to say that we have impressive career placement. And so I'm going to just talk briefly about each of these, and then we can move on to the rest of the presentation and then questions afterwards. So in terms of education, I think we're a fairly innovative College of Science. There are many cross-college majors that one can also do, but there are 33 different options, at least as I count them, to major in science, which is everything from different tracks and different departments. We have some interdisciplinary majors within the college. There are a lot of ways to study science that you could forge your way through the university. Our faculty are incredibly dedicated to teaching. I think it's safe to say that we are leaders in creating new ways of teaching and adopting new and exciting ideas of teaching. And so our classes are very interactive. We really emphasize active learning, and we aspire to and pride ourselves in presenting an excellent education. And we really have multidisciplinary approaches to learning, hands-on. We have research classes. We have mentorship opportunities for undergraduates so they can help the younger students learn. So there's a lot going on here to provide a very rich fabric of undergraduate education. And I'd like to point out that the physics department was recently ranked 11th in the nation in the quality of the undergraduate experience. So we really think that our majors have fun, believe it or not. They get to know each other. There's a great cohort of students that develops around the major. And so one of the things that's sort of reflected in that is that we have spaces where the students can congregate. On the right-hand side of the slide, you can see the Jordan Hall of Science. So this is a 200,000 square foot teaching building. It's completely dedicated to lectures and laboratories in science. It has 40 different laboratories for undergraduate science education. Some of the research-oriented classes are in here, pretty high-end labs in terms of your core labs that you take towards the end of your undergraduate career with some fairly research-grade equipment where you can do real experiments. And it's really a beautiful space. The dean's office is in here. But there are spaces in here where the students meet and can hang out and study once we're post-COVID. But anyway, so this is kind of an unusual building because it has all the science labs in one place. So it allows us to do some very innovative things. So let's talk about the faculty. We have experts without all of those 200 people and everything from atheromas to zebrafish. And our faculty are nationally known and nationally respected. They serve on various advisory committees for the funding agencies and the federal government, National Science Foundation, Department of Energy, National Institutes of Health. They advise many of the international aid organizations, UNITAID, the Wellcome Trust. So we're involved in international science, but we're also involved in international science policy. So it's a very distinguished faculty. They've also won many national and international awards. And so I'd like to highlight Professor Nora Bazansky, who was recently appointed to the National Academy of Science. As you probably know, that's one of the highest honors a scientist can be given in the United States. And so we're very proud of Nora. And anyway, this is just an example of the stature of the faculty. So let me talk a little bit about research opportunities. I think one of the strengths of our undergraduate program is that we believe that students learn how to do science not by reading it in a book, but by getting into the lab, rolling up their sleeves and getting their hands dirty. Now, whether that's a computational lab or a wet lab or a stream is a different question, but there are lots of opportunities, and we hope that every undergraduate in the college can take these opportunities, take advantage of these opportunities to really enrich their education, to really get a feel for what it means to do science. So I'll just sort of walk through a few of these. On the health front, one of the things that we have here are many centers that are working on specific scientific problems. Many of them are actually related to health. So we have the Harper Cancer Research Institute. We have the Bowler-Parsegian Center for Rare and Neglected Diseases. We have the Warren Family Center for Research and Drug Discovery and Development. We have Center for Stem Cells and Regenerative Medicine. And then within the departments, biological sciences, chemistry and biochemistry, and even applied and computational mathematics and statistics, there are various people working on health problems or the basic biology or chemistry of health. And so all of these are sort of in a vast net of research opportunities for health. This also includes the IU School of Medicine. There's research down there. Some of our students go work in those labs. So all of the faculty who are involved in these centers have research going on various problems around the health front where students are invited to come in and do research. We also have a focus on energy and the environment. And so biological sciences, even the physicists got into this. We have a nuclear physicist who's using applied nuclear physics techniques to screen for toxic chemicals and lead. But we have people working on materials for solar energy, trying to study how you may have the power flow in and out of wind grid systems. And a lot of people in ecology looking at agricultural conservation practices to really keep the nutrients in the soil and prevent these sort of giant algal blooms that you see out in the Gulf of Mexico, for example. And then, so I'm going to make a distinction here between small science, which means we work on very little things, and big science coming up on the next slide. So we have extensive experience in terms of different material sciences, semiconductor nanowires, nanomaterials for energy storage, some very interesting chemistry. Now, as I go through this, remember there are 200 faculty, each of which has an independent research program. So there's no way I can cover all of that in this talk. I'm just giving you a little sense of the kinds of things we can do. So we do small science, protein folding, bioinorganic chemistry, and then on the next slide, we've got big science. So I am a particle physicist. I work at the Large Hadron Collider. We do dynamical systems of meteorological modeling. Notre Dame has 2 environmental research centers, very large tracts of land in the west, in Montana, and in upper Wisconsin, where there's an opportunity for basically untouched wilderness and environmental research. Our astrophysicists work with the Large Binocular Telescope and other large telescopes around the world. So we do small science, focusing on the nanoscale, and big science, focusing on giant experimental techniques, looking at the galaxy, particle physics, clouds, hurricanes, and things like that. So, and everything in between. So I could have told you about work on primates or other diseases. There's a broad variety of things that we work on. So with that, I think I'll step away from research here and then go on to career placement. So we are training the scientists and leaders of tomorrow. And we challenge our students to meet to achieve their potential. And whether it's in science or in leadership, there are many opportunities for activities in and out of the classroom. And so this is our goal. in doing that, our students attend some of the most prestigious graduate programs if they're going on to academic careers. We also have an outstanding success rate for medical school placement, with 85% or above in some majors of our students are accepted into medical schools. And if you're not doing one of those tracks, our students do everything. They become lawyers, engineers, entrepreneurs, journalists, teachers, you name it. You can find a Notre Dame grad out there. And you can find a Notre Dame science grad out there who has gone through the college and is out there succeeding in the world. So with that, I'll stop talking, and thank you for your attention. I'll hang around and answer questions later on. And I'll now pass the baton back to Dan, and so he can talk about some of the undergraduate programs in more detail. Thanks.
Thank you, Mike. So my name is Dan Gezelter. I'm a theoretical chemist. I'm also the Associate Dean for Undergraduate Studies in the College of Science. So I deal with things like majors and making sure everybody graduates on time and all sorts of things like that. So one of the things that a lot of students have questions about is, well, majors and what do I study and how do I craft a program specifically for my research interests? And the answer is there's an infinite number of ways you can do that here. I mean, well, actually, it's not really infinite, but it's very, very, very large. So I thought I'd go through the 5 departments and talk about the major programs that are available in those departments. And students have crafted their own programs out of combination majors and minors, and you can do a lot of different things with one of the science majors as your core discipline. So I'll start with the Department of Applied and Computational Math and Statistics. It's a mouthful. So ACMS is the parts of math that are not pure math. So anybody who studies math involving a computer or involving things that are simulated, or things that have where we study large quantities of things with statistics. So ACMS has 2 different majors housed in that department. One is an ACMS major itself, and the other one is a statistics major. Okay, so stats. And either one of those 2 majors can be your primary major, or they can be added as a supplemental major to another one in the College of Science. So these are actually very popular supplemental. You can have chemistry with an ACMS supplemental major. So that's very common thing to do. The Department of Biological Sciences studies living things in all forms. There's a core biological sciences major, and within that major, there are 6 different tracks that you can take, including things like ecology and evolution and microbiology. You can do a lot of different tracks in the biological sciences major. Biology also houses 2 other programs. One is a major in environmental sciences, and then there's also a minor in sustainability. The Department of Chemistry and Biochemistry is a combined department, has both of those fields in it, and as such it has 2 primary majors, the chemistry major and the biochemistry major. And we found recently that a lot of students have been interested in neuroscience, and so both of those majors, chemistry and biochemistry, now have concentrations in neuroscience that are brand new this year. So you can do biochemistry with neuroscience or chemistry with neuroscience. There are also 2 sort of career track chemistry majors, chemistry with business, which is a partnership with the Mendoza College of Business, and chemistry with computing, which is a partnership with the computer science department. The Department of Mathematics has a lot of tracks. So it has a primary math major, and to that math major, you can add concentrations, and you can add multiple concentrations to that major. So that may include math and computing, or math and business administration, or math and life sciences. The math department also houses the minor in actuarial sciences, which involves a lot of business classes as well. The Department of Physics has a physics in medicine as well as a physics major. And within the physics major, you can concentrate in advanced physics, applied physics, astrophysics, or computing. We also have a separate department called the Department of Pre-Professional Studies. And it's actually one of the smallest departments, but it has a large number of students who study in that. This is largely for students who are interested in going on to the medical professions. So science pre-professional is actually one of the more common majors at Notre Dame. There are a few majors in the college that are outside of a department. These are people who want to have sort of general background in and training across the sciences, and also concentrate in something else. So science business, science education, and science computing provide a core sort of fundamental set of courses in the sciences, and then let you specialize in something that might be outside the sciences. One of the non-departmental majors that's housed within the College of Sciences is neuroscience and behavior. And that's actually the largest major in the College of Science. This took us a little bit by surprise. Neuroscience and behavior has only been around for, I think, about 8 years total, and has suddenly become, in that span of time, one of our more popular majors. So just as no matter what you do here, you're in good hands. We've got, this just tells you a little bit about how many majors we've got in the current programs. This combines the sophomores, juniors, and seniors together in this plot. First year students don't actually have a formal major within one of the colleges yet. They're considered, they have an intent. They might be a chemistry intent in first year of studies. And then at the end of the first year, they declare a major and become somebody in the College of Science. Okay, so our largest major is neuroscience. After that is biology. And then two of the non-departmental science general tracks, so science business and science pre-professional. And then these are just the largest of the majors. So there's about 400 students per year in the college. So one of the biggest questions we get is can I double major? Can I do a minor? Can I do a major with 2 minors? And the answer is usually yes. Sometimes it requires a little bit of gymnastics in your scheduling to make things work, but almost 65% of the science majors are carrying a second major or minor. And you don't have to. In some cases, we actually want a student to concentrate in one area in great detail, but students seem to like having a lot of sort of badges on their diplomas. So it is possible to do lots and lots of different kinds of study here. So within the College of Science, there are some common combinations. So physics and mathematics is fairly common. However, the most common double majors are across science and arts and letters. So somebody might have a biochemistry major and a Spanish major, or biology and theology. There are also some really quite popular minors. So science, technology, and values is one of the more popular ones. The minor in sustainability, which is actually housed in this college, is also quite popular. For people who are interested in going on to medical school, we have actually a really interesting minor in the compassionate care and medicine run by Dominic Bichon, and he's actually going to be involved in one of the sessions tomorrow. So if that's something that's interesting to you, then I'd urge you to go to that. All right, so one of the things that Notre Dame is really proud of is how many of our students are involved in undergraduate research. As Dean Hildreth said, the way you learn how to think like a scientist is to actually get involved and get your hands dirty doing science. So almost every faculty member in the college takes on undergraduate researchers. I have 4 in my lab right now, 2 juniors, 2 sophomores. We are really happy to get undergrads in our labs. They're bright, they're driven, they learn a lot, they contribute, they get their names on papers. There are fall and spring undergraduate research symposia that are run by an employee of the college, Dr. Cheryl Liu. And in those undergraduate research symposia, we have poster sessions, we have talks. They're run like real scientific conferences. And students learn a lot from each other, and faculty go just to see what their colleagues are doing by way of their undergraduate students. We have lots of research opportunities outside Notre Dame as well. So a lot of our students do REU programs. This is research experience for undergraduate programs at other institutions. So this is a very common thing. You do coursework and maybe some research here. You get a feel for what it's available at Notre Dame. And then if you find a program that has a summer spot, you can take a summer and go someplace else. So popular places to do that might be the MD Anderson Cancer Center or Cold Spring Harbor Laboratory. We also have people who go to all sorts of medical internship or shadowing programs over the summer. So these are things that are accessible to our students, and we help you get involved in those things as well. Science is a global enterprise. I don't think a single faculty member I know of who doesn't have some collaboration or good colleague who they bounce ideas off of outside of the United States. So if you're interested in particle physics, we send students to CERN. So in chemistry, we have a project on something called paper analytic devices, which is an inexpensive and a very easy to set up with few resources analytical chemistry lab on a piece of paper, and it's being used to test for counterfeit drugs in Kenya. So we've sent groups of students with Professor Maria Lieberman. There have been some malaria studies in humans and mosquitoes involving student trips to the Solomon Islands. A lot of science students are interested in careers in medicine. And even if you combine all the pre-med students in all of the largest majors, so neuroscience and science pre-professional and biology, that's a lot of students. It's around 260 per year are interested in going to medical school. So our medical school admission rate is very high compared to other schools in the United States. So this is across the university. Our acceptance rate is about 83.7% last year. In some majors, it's higher. So if you're interested in a biochemistry major, the biochemistry major has a specific coursework right before you take MCATs that helps students do particularly well. Our placements in med schools are amazing. This is just last year's placements in some of the top med schools. We do pretty well. And one statistic so Father Jim Foster is the chair of the Science Pre-Professional Program. One statistic that I've heard about this program is that Notre Dame supplies 1% of all entering med students in the United States. So if you are interested in a career in medicine, this is a great place to do that. It's not the only thing you can do, however. So we are happy that a lot of our students are engaged in science as a discipline because they want it as a career. They want to become working chemists or working physicists or biologists or mathematicians. So we do send a fair number of our students, somewhere about a quarter of our students in the College of Science go on to further training in a scientific discipline. And there are lots of ways to do that. So science, if you go to graduate school in science, you get paid to do that typically. So graduate students in science often get paid to go to school. It's a shocking thing to some people. We've done very well with Fulbright scholars lately. We have 2 Goldwater scholars from last year. Notre Dame undergrads have won 12 graduate research fellowships last year. We've had a Rhodes Scholar in the past year and a Gates Cambridge Scholar as well. People who apply to grad school from Notre Dame typically get into a lot of great places. All right, so while I've got you in this audience, I thought I'd talk a little bit about some other things at Notre Dame that are worth probing while you're sort of thinking about where you want to go to college. So a lot of Notre Dame students are they want to heal the world. They're service oriented. They're great people, and they want to get involved in serving other people. We have something called the Center for Social Concerns. This is a program that helps coordinate summer service learning programs, including some international summer service learning programs. These are programs where you go and build a bridge or do some science as in service of others. And then you get course credit for that when you come back, and typically you have to write up what you've been doing. We have something called the Flatley Center for Undergraduate Scholarly Engagement, so CUES for short, the Center for Undergraduate Scholarly Engagement. And this is a center that is expressly there to help you sort of apply for and win these prestigious national fellowships. So things like the Churchill or Goldwater Fulbright, an NSF Graduate Research Fellowship. And they, Notre Dame's among the top producers of Fulbright scholars for the 4th year in a row. It's actually, so CUES does an amazing job helping students. So one question I get from a lot of parents is, what can you do with a science degree? And the answer is just about anything, right? So we've talked about medical school, we've talked about graduate school. So graduate school is a great way to go into academics or research. Students can go to all sorts of professional schools, not just medical school, but also law school, business school, dental school, veterinary school, PA programs. A lot of our students go into the private sector as consultants, or they work for pharmaceutical companies. Some of our students start their own companies. Some work for governments as science advisors. Some have started NGOs or science reporters, and even one of our College of Science alumni owns a football team. So we're proud of that as well. All right, before we jump into opening this up for questions in the chat, I thought I'd point out the other sessions that are coming this week. You should have received an invitation that includes the Zoom links to all of these programs. So, and they're sort of broken down. So Tuesday, tomorrow, there are going to be 2 different Zoom meetings. One which sort of details a science pre-professional major and the minor in compassionate care and medicine. That's being run by Susan Gursky and Dominic Vachon. There's a separate one, so that's from 8 to 8:30 tomorrow. There's a separate one starting at 8:30 to 9:30, which is being run by the Assistant Dean, Kathleen Kohlberg, and Associate Dean and Chair of the Pre-Professional Program, Father Jim Foster. This will be preparing for health professions. And you don't have to, you can be interested in any major, but if you're interested in med school, that's a great presentation to go to. On Wednesday, we have sort of a smorgasbord of other sort of departmental majors. So ACMS, biological sciences, physics, and the sustainability minor will have their programs on Wednesday. And these can be sort of drop-in sessions. So you can go to multiple sessions. You can go to one, spend 15 minutes with Alan Hubner and ACMS. And then if you would decide that physics is you're interested in physics, you can sign off and join Philippe Colon on the physics one. On Thursday, we've got chemistry and biochemistry, environmental sciences, math, neuroscience, and then the science non-departmental programs, so science, business, science, computing, and science education. And those are, so that one's from 8 to 8:45. The others are all from 8 to 9:30. All right, so there's lots coming this week. And if there's a question that shows up in the chat window that I can't answer, then in fact, I'm probably gonna tell you to go to one of these other sessions because they know a lot about what's going on. All right, so at this point, I think I'm gonna just tell you about how you can keep in touch with us. We have a social media presence, although people like Mike and I don't know what we're doing on social media, so hopefully students are involved in all of these as well. And at this point, I'm going to invite Mike back, and what I think we're going to do is I'm going to stop the share here. And if you have any questions, you can go ahead and and put them in the chat window. And depending on which one of us wants to answer, we'll ask the question of each other. Do the chats work? Or you can unmute yourselves. All right, Mike, I'll ask you a question while we're waiting for people to type their questions in the chat.
All right.
What was the most surprising thing to you about Notre Dame when you came here?
I think I was amazed at all the different things that were going on because, I'd spent 5 years in Geneva, Switzerland, before coming here as a faculty member, and CERN is a great place, but it's a particle physics lab, and so they don't do much else besides particle physics, and so just sort of realizing that there was all this cool science going on and all this cool other stuff. That's one of the nicest things about being at a university is that you can walk across the quad and suddenly have a conversation about Enlightenment philosophy or Italian architecture, which is not something that you can do at a national lab or anything like that. So the sort of it was just great to be back at the university. But I was also just who knew that people would study all these kinds of things? Even in science, there was just a lot happening, and so it was fun to actually get back here and talk to people.
All right, we've got some great questions. So Samuel is asking, can you work in more than one lab at a time? So you can. It's not very common. So typically students enroll in research as a course. So in chemistry, that would be Chem 48498. And what we normally do is we expect students to sort of devote themselves to one lab while they're taking that course. But students have been known to and often do switch labs. If they find another research area or another department even, they can switch to another research advisor, usually at the boundary between semesters. So yeah, you can work more at the same time is pretty rare. I think I've only seen it once.
Yeah, usually you want to take a little bit of time to get to know what science you're doing, and so that requires a focused effort. So it's really difficult to do that twice. I mean, often in our group, we have students just work on a volunteer basis that first semester so that they can get a feel for it. So they're not locked in to credit or anything like that. And then if they hate it, they can go off and do something else the next semester. But we just want to provide that experience. So we want to make sure that people have a chance to dip their toes in the water and enjoy it. But now we have a lot of questions.
Yep. All right. So Thomas asks, what percentage of science majors spend a semester abroad? If you'd asked me that 2 years ago, it would have been 40% spend at least a semester abroad, or a summer or a fall semester abroad. Last year and this year kind of screwed everything up. So right now the percentage is kind of zero, but hopefully that will go back up to the 40%. There are some programs that are more common for science majors studying abroad. So Dublin, London, and Perth, I think, are the more common ones for students, mainly because they have science courses that we know about and which count for credit, major credit at Notre Dame. So if you take a biochemistry class at University College London, it's actually taught by a Notre Dame alumnus. So we know what that course is. So those are.
We send students to Geneva. You have to learn a little French to do that, but then they end up working at CERN or other areas in and around Geneva. So there are lots of different options.
Okay.
Um,
Anna sent me a great question directly. What are some of the most impressive, coolest undergraduate research students have done? You want to answer that, Mike? I got a whole list of them.
go ahead. Go ahead.
So I had an undergrad involved in my lab who found a new structure of ice. So that was pretty cool. I mean, that was pretty amazing. There's been some amazing. There was an astronomy kid a couple of years ago who was just astonishing.
Every year, we are more and more impressed with the undergraduate projects and the research that people are doing. So it is really, people do particle physics theses, people to help develop cures for diseases, understand fundamental biological systems. Yeah, it's really very impressive. Wait, so are double majors between a science and music common or even possible? Yes. Yes. You can do that.
Okay, so Caroline asked a question about our students assigned an advisor specific to their major. Yes, so first year advising is also sort of not entirely, but mostly major specific. But then once you declare a major, the departments in the College of Science have advising staff specifically for students in that major. All right, you answered the music one, right?
Do students who double major still tend to graduate on time? Yes. You got a plan, but yes. It's actually relatively easy to double major between science and arts and letters because the arts and letters majors don't require anywhere near the number of credits that a science major does. But yeah, you can certainly do it. You just require, you have to plan.
So Daniel says, I know that you're required to take sequences in subjects like chemistry and physics, but are you able to test out of one of those sequences, let's say physics, if you take AP Physics 1 and AP Physics? So that requires some qualification. So typically you can test out of something that you are not majoring in. So chemistry will not let you test out of chemistry. Physics will not let you test out of physics. So,
although we do offer an exam. So if people really are advanced in physics, we'll just give you the final exam from the previous semester or something like that. And if you ace it, then yeah, you're good. So not very many people do that, but but yeah, I mean, the majors courses are very rigorous. And so it's in your best interest they're way more rigorous than an AP course. And so if you're majoring in that subject, you really want to take the majors course because they're much more in depth and cover a lot more material than you would get in a standard AP course.
And I should add, you don't have to be a major to take the majors course. So in chemistry, Chem 10171 is the non-majors large lecture Gen Chem class. Chem 10181, so it's only different by one digit, is the major section. It's a much smaller section, but it moves fast and it dives deep. So it is a very intense Gen Chem class. So even if you've had a strong AP chemistry background, you should take that class, even if you're not a chem major. All right.
So someone who's interested in dentistry, orthodontics, does Notre Dame provide certain opportunities for these interests? Yes. Yeah, we have a lot of pre-dental students, and yeah, that's a thing. We definitely have support for that within the pre-professional advising.
Yeah, and if you're interested in dentistry or orthodontics, I would definitely go to the sessions tomorrow. Considering the pre-professional sessions tomorrow are going to involve not just pre-med, but also pre-dent and pre-vet. Okay. Katie, can international students work in scientific research labs?
Yes.
That was easy.
Yeah, that was easy.
All right, Margaret, what is the biggest misconception regarding the College of Science?
Good question.
The biggest misconception?
Well, maybe you can clarify what you mean by misconception of the students, misconception of the perception from outside. I'm not really sure Here, I'll go out on a limb and say the biggest misconception is that scientists are nerds, but we're not, really. Some of them are, but there are a lot of not nerdy people in the College of Science. So Dan, for example, is the faculty advisor for the bagpipe club. I'm actually the faculty advisor for the juggling club. So there you
We
go.
have some odd interests. I don't think that gets us out of the
I actually
nerd.
I can't juggle, but they asked me to do that. So,
Right.
so
I don't think this gets us out of the nerd category. All right, so Ella is asking, can students conduct some of their own research projects with research advisors, or are students only able to participate in faculty's research? That's a great question, because some faculty conduct their groups very differently than other faculty do. So some faculty will pair an undergraduate student with a graduate student on an existing project. Some faculty will say, okay, I've got 3 undergrads, I'm going to put them together in an undergrad pod and let them go do their own thing. Some faculty have primarily undergrads, and each undergrad has their own project. So everything depends on what's going on in that lab. So before you join a lab, it's worth having long conversations with the previous students, the advisor, the grad students, about what the style of advising is. So you got anything to add to that, Mike?
No, I mean, I know of examples of students who have pitched research ideas to professors, and the professors were like, all right, yeah, let's try it. So yeah, if you have a great idea and you can be persuasive enough to persuade that faculty member that it would be interesting to pursue, and it's like related to the topic, obviously, because so if someone asked me something about malaria, I wouldn't be able to help you. But you know, if you pitch a particle physics idea, it sounds cool, we could try it. Absolutely.
Okay, Evan is asking about, is a double major with Mendoza feasible? So the more common route for that is either there are a couple of business concentrations in science majors. So we talked a little bit about science business. There's also chemistry business and the math business administration concentration. And those are all very similar, that they've got a core set of 5 or 6 business courses that you take. And in addition to what's essential, so you're essentially replacing some of the electives in the major with those 5 or 6 business courses. So those are cooperative with Mendoza. The idea is that we have a fixed number of slots in Mendoza that we can give to students who are doing science, business, chemistry, business, math, business administration. The science business program is a single degree. You get a Bachelor of Science in Science Business. So it's a single degree. That was Hannah's. Those are
Good. I don't think you can actually double major in Mendoza and the College of Science.
No, the way to do it is with one of these combo programs. All right, Katie sent me a great question. In your opinion, what is the coolest class available in the College of Science?
Well, you created it.
Well, I've got a nominee, yeah. The chemistry of fermentation and distillation, which is the beer, wine, and whiskey class. So you have, in order to take this class, you have to have had an entire year of chemistry at Notre Dame. So it's restricted to people who've been through mostly one of our majors or the engineering majors. So it's a great class. We do tours of microbreweries and wineries. Actually, Holly Goodson, who is Dean Hildreth's spouse, is involved in this class as well.
She's a biochemist.
She's a biochemist. She's a consulting biochemist at a local winery. And we had an organic chemist was involved as well. It was the most fun course I've ever taught. We get a lot of seniors. Any other questions? No? if you intend to major in neuroscience, for example, how easy would it be to explore other areas in both the College of Science and the College of Arts and Letters in your first year? Great question. So neuroscience is a cooperation between the biology department and the psychology department. So courses that have the neuroscience sort of imprimatur, they typically have prerequisites in both areas, or one area or the other. And in fact, there is an arts and letters version of neuroscience and a College of Science version of neuroscience. It is, I think it would be easy to explore other areas in the college. Those majors are already, I mean, neuroscience is already very broad. It has lots of things that count as a neuroscience course.
And basically the introductory science curriculum is fairly common across all of the science majors anyway. So if you're taking like little introchemistry, little introbiology, that's the basic track for pretty much anything. Sprinkle in a little physics later, potentially. You'd be on track to do a biology major or neuroscience. So that, yeah, you can explore it. As long as you take some of those introductory science courses in your first year. If you put those off, then it becomes more difficult. You're less flexible without those base courses.
Okay, Quinn's got a question. How difficult is it to switch majors within the College of Science if you become interested in another aspect of the field? So to switch between departments, between majors, and it's easy to do that early. The longer the longer into your career that you wait to do that, the harder it becomes. And the reason that is that there's some core courses that are common across all majors, just like Dean Hildreth said, that you have to take a general chemistry class and some calculus and some intro physics, and everybody has to take those, right? And once you get past sophomore year, well, you've got more sort of field specific things, and the majors tend to diverge a little bit. So it can be, you might be playing a little catch up if you wait until junior year to do this. But in the first 2 years, I think I wouldn't say it's common, but it's not an insurmountable thing to switch majors in the College of Science in the first 2 years. Later on, it's harder.
So I have a nerdy question. So what is the focus of my research? So as I said, I do experimental particle physics. So I do work on the CMS experiment at CERN. I was part of the discovery of the Higgs boson. Right now we're studying, we're actually looking for new physics, exploring the interactions of top quarks and the Higgs boson. So that's one of my research areas.
There was a hidden one that was direct to me. How does Notre Dame prepare students for applying to medical school? So Maggie, I'm going to suggest that you go to the sessions tomorrow. Those are where Father Foster and Kathleen Kohlberg, they will give you every possible detail. They're the geniuses at getting students into med school. So I'm going to punt on that until tomorrow.
There are many ways.
There are many ways. Yeah, they are wonderful at providing advice and putting together the packages. And
there's incredibly nice people as well.
Yeah.
If you're planning to be an actuary, is it better to major in ACMS or within one of the mathematics majors?
Well, that's interesting. The minor in actuarial sciences is actually in the math department.
Right.
So if you want to be an actuary, that's I would say start talking with people in the pure math area. Sonia Mapes, she's going to be giving one of the sessions, I think is on Thursday. Yes, she's on Thursday. She would be the right person to ask about the actuarial sciences minor. I think you can do that minor and a major in ACMS if that's something that's interesting to you. So you could potentially do applied math and actuarial sciences minor. Any other questions?
Other questions?
All right, Mike, what's your favorite class to teach?
Oh, here's one.
Oh, okay. Answer the real question first. Okay. So there are science halls dedicated to particular fields. What would you say is for biology majors, the typical share of lectures, labs between facilities? Jordan, Galvin.
So all of the teaching labs are here in Jordan Hall. So if you're taking a lab class, you're taking it here. Whether it's chemistry, physics, or biology, all of the labs are in this building. The research labs for biological sciences are all in Galvin. And so if you're doing research in one of those labs, you'd be in Galvin. Galvin has one tiny lecture hall and like one classroom. So depending on what classes you're taking, you could get lucky, but usually the biology classes are sprinkled around. Some of them are here in Jordan, some of them are in one of the other teaching buildings around campus. I mean, campus isn't that big for the most part. So unless you live really on one of the really, really far away dorms, it's pretty easy to get back and forth.
If you're in Carroll Hall, it's a challenge.
Yeah, but yeah, Carroll's pretty far.
Right. Okay.
One piece of advice you would give to incoming students.
Go to office hours.
Go to office hours.
Yeah. That's where professors get to know the students. So office hours are sort of mysterious to a lot of students when they first get to college. But typically they're just times where you can go hang out in a professor's office and ask anything. And so for my Gen Chem classes, I allow students to come. I encourage them to come do their homework in my office. And if they get stuck on something, they can ask me a question. One of the reasons that's so great is that it gets you sort of talking to a professor in a really sort of much more sort of casual setting. Lectures can be pretty intimidating. So office hours are where a lot of sort of great interaction happens.
I guess I'll toss in a piece of advice that don't be afraid to try new things. That wacky course on Renaissance gardening and landscape architecture looks interesting. Go take it. There are so many interesting professors doing interesting things that are not in science. You should really take advantage of it, because it's the last time you'll have that much freedom to study random things. Once you get out of here, it's those opportunities close down. So it's you'll have a world expert on whatever it is at your disposal, which is just great.
So Mike, I've got a private question here from about how does the curriculum vary if you're in the Glenn Honors Program?
So I know a little bit about that because my wife was one of the Glenn program directors for a little while. So the Glenn Honors Program has separate seminars that they run, and they have a thesis that they have to write. And when they're finishing their undergraduate careers, they have separate tracks for some of the math and science courses as well. So there's a Glenn math course and a couple of Glenn kind of interdisciplinary science courses as well. So it's you have a little bit of extra enrichment in the curriculum and some much smaller classes. So you should check with the main advisors to see what they're currently doing, but that's the sort of thing that I remember. But the big thing is you have some separate special small classes, and you have to write a thesis, an honors thesis, at the end of your career.
Okay, Henry. Does the policy mentioned earlier about AP science classes apply to calculus? Oh, no. So calculus is one of the few things where you're encouraged to go into the course that's sort of the next one in the sequence for you. So if you've placed out of Calc 1, take Calc 2. If you placed out of Calc 2, take Calc 3. Right. So don't repeat material. You still have to take some math, take at least one math and probably more if you're in most of the sciences. So
the statistics also satisfies a math requirement too. So
yeah.
Most people don't find a hard time taking a math course.
Right.
There are a lot of interesting ones that are offered that aren't calculus.
Okay, John is asking, how would you suggest incoming students to prepare for college during the summer before freshman year? It depends on where you can go post, how far we are post-COVID. Right?
Yeah.
Travel.
I don't know that. Yeah, I don't know that you would, don't work too hard.
Right.
You might want to look forward a little bit to the classes that you're taking. If you're concerned about them, do a little brush up work, but enjoy your vacation.
Yeah.
You'll be working hard enough as it is by the time you get here. So I wouldn't stress over it.
Spend time with your families.
Yeah, exactly. Because you're not going to be spending much time with your families once you land on campus. So
everybody might be sick of being in their same house with their.
That's right. By the time they'll be ready to get out by the time COVID's over.
All right, Grace. Do credits in math and science courses taken at local colleges and universities transfer for courses required for your major? That depends. Courses taken before arrival at Notre Dame, college courses taken before arrival at Notre Dame, some of them can transfer. Once you're a student at Notre Dame, once you've enrolled here in our programs, all science courses must be taken at Notre Dame. So these are one of the rules. So if you come in with a course, that you took in high school and dual enrollment or at a local college, you'll get, I think you can get up to 2 of those courses counted. But once you're here, you're expected to take all of your science courses at Notre Dame. All right. Does that answer that question? All right, while we're waiting, Mike, what was your favorite course to teach here?
So I've only actually taught freshman physics the entire time.
Really?
Yep. Freshman physics for engineers or freshman physics for physics majors. I've sometimes taught the labs, but I've only taught introductory physics. So I think probably the lab course is the most fun because we really have students designing their own labs for a lot of it. So it's very inquiry driven. Yeah, so I don't know. I like those intro courses, so that's all I've ever taught. So 20 years of teaching.
All right, so I can't ask you what your least favorite course to teach is. So Anna is asking, what is the average lab size that students share? So in the teaching labs, I think that's the, so I wish we could take you on a tour of Jordan Hall because it sounds like a big number, but Jordan is the most luxurious lab teaching facility I've ever seen. So the lab rooms here are enormous. So each of the chemistry lab rooms holds 24 students, or normally holds 24 students. This past fall, they held 12 at a time, and we sort of alternated week to week who was in that room. But each of the 4 lab rooms are connected to something called a data analysis room. So the section, your lab section in general chemistry is about either 48 or 96 students, one of the two, depending on if you're in the major section or the non-major section. And those 96 students meet together in the data analysis room for the pre-lab lecture. And then they split up. So they leave their sort of laptops and their backpacks in the data analysis room. They split up and go to the individual lab rooms in groups of 24. And these are just amazing labs. They are, there's a fume hood for every single student in the chemistry labs, which is unbelievable. There's shared balances for, one balance for each 8 students, which is, I've never seen a line for them, which is great. They're just sort of remarkably well designed, well equipped undergraduate laboratories. So then when you're done with lab, you sort of reconvene in the data analysis room, you do your write-up, you submit it. These days it's all electronic, so there's a lot of work on your laptop. And the reason we don't want the laptops in the lab room is because there's acetone in the lab room, and laptops and acetone are generally not a good idea to put together. In physics, what about physics?
Physics, the typical lab section, I mean, you called it a airplane hangar. We were talking about the spacing, but those can hold up to like 40 students, but we usually don't put that many. We usually work in like groups of 2 or 3 the experiments, but there's a lot of space. And each of these classes has probably 1 TA or a professor per like 10 students, something like that, 10 or 15 students. So there's a lot of help there in the labs as well.
Daniel's got a good question. Is there a recommended laptop for students in the College of Science? Nope.
No, anything works.
Yep. Anything with a web browser works these days.
Yeah, that's right.
We see sort of a large collection of things. So there's nothing that doesn't really work anymore. Does the College of Science hire any students for on-campus jobs? Yes.
Yes.
Yeah. Including, so research during the year is typically a class, but during the summer is usually paid. So summer research jobs are a thing here. So you get paid to stay over the summer and work in a lab.
We also have undergraduate TAs who get paid, undergraduate graders sometimes who get paid. We have, I know that in my wife's lab, they have like the dishwasher. So she takes care of washing up all the glassware from the experiments. That's a paid position. So yeah, there's all kinds of stuff like that that's possible.
All right, so Lori's pointing out that the college is actually putting together a virtual tour of Jordan. And
oh, good.
So you guys should look out for an email soon, I think, of this virtual tour that'll show you some of these lab facilities and show you like what Jordan looks like. It's really an amazing building.
I think there may be even some videos on YouTube if you Google Jordan Hall of Science, Notre Dame. There might be some videos out there already, but a longer virtual tour would be cool. Do professors focus on certain course or a couple of courses over years, or is it common for professors to teach multiple different courses? It varies. I only ended up teaching introductory physics forever because no one else likes it. So that's not really true. But it's a challenging course. There are a lot of administrative overheads. Usually people teach the same course 3 times and then switch. But I would like switch back and forth between introductory courses. So that's been my switching. But yeah, people vary, and some of the courses are more specialized. I wouldn't do so well teaching quantum field theory to graduate students, but there are people that's their specialty, so they tend to teach courses in their specialty as well.
Right. That's same answers during chemistry. We typically have a 3 years on, and then you do something else. So we teach the same courses for 3 years in a row, and then we do something else. Do generalized classes tend to have larger or smaller class sizes? So depends. So the big general chemistry class comes in a couple of different flavors. So there are typically 4 or 5 sections that are pretty big. So section size is around 250. And then for students who are majors, we have a smaller section that's around 80 or so. So that's kind of medium. And then as you sort of progress through the fields, those courses tend to get smaller just because they're more specialized as you go forward.
Many of the larger classes, though, have we call them discussion sections that break down into 20 or so students each week. So you have an opportunity for a small class setting, even in the 250 person class.
Right. And I think that's true of all of the big classes. They all have discussion sections or tutorials that are
Right.
20 to 30 at most. Okay, Joanna, how do you get involved in research as a freshman? You send email to a professor. Freshman year is, I mean, you don't have to get involved that early. Some students do. Sometimes you want to wait until you've seen a couple of courses in a field to make sure that's actually what you want to do. But we have students who get involved sort of halfway through freshman year, that they look through the web pages for a particular department, find somebody whose research sounds interesting, maybe read a few papers, and then just send email and set up a time to, well, was a time to meet. Now it's usually a time to Zoom with with the professor and say, well, I'm really interested in your stuff. Do you have any openings in your lab? And more often than not, the answer is, yeah, I think I do. So what do you want to do? It's really that simple. Getting involved in research is not the barrier is intentionally kept very low.
So I got one. What are characteristics and or habits of students, mainly freshmen, who are successful in your courses and in this program? I don't think I can. I don't think I can make a short list of characteristics. I think there are many different ways to succeed. I think, perseverance, passion for what it is that you're doing. I think that's the most important thing. Again, believe it or not, my worst grades in college were in physics. So didn't hold me back. So you can become dean of the college with the not the best physics grades. So if you have a passion for what it is that you're doing, I think thinking carefully about how you study, and one of the things that took me a while to figure out was to understand how I really learned, because I think a lot of the students, I think this is a common thing for high achieving students, when they're first faced with material that they really have to grapple with. It's just like, I just don't understand this. Trying to figure out how you, and everyone is different, how you navigate that and figuring out what you have to do to understand the material. It took me a long time to figure that out. And so I think, so it's a willingness to, be lost and then try to pull yourself out of it and figure out where it is that you're going. I think that's the most important characteristic. If you're used to just kind of skating by and life is easy, you will eventually find a piece of life that's not so easy. It's what you do at that point, and how you confront that, I think, is the most important marker of success. That was pretty philosophical, sorry.
Yeah, actually, to add a little bit on this, the students who are knowing when to ask for help is a good skill. Everybody's going to get to a point where they're out of their depth on something, and for me, it was organic chemistry. And again, I'm a chemistry professor now, so um, knowing when to ask for help and knowing when to sort of go to a professor and say, I just don't get this. Because sometimes just hearing it in a different, in a rephrased in a different way is all that you're just not understanding something that the way it's being phrased. So knowing when to ask for help and also asking for help widely, not just from your professor, but also from your friends, from your TAs, from, because sometimes you'll get that rephrasing of the material from somebody who just learned it, who sits next to you, right? So your peers are often really great at resources. All right, Suzanne asks a good question about, are there advantages or disadvantages to majoring in science pre-professional versus majoring in the hard science such as biology or chemistry? So yes and no. Yes, because some of those programs have courses that are have additional courses that are meant to teach you about subjects that are on, say, the MCATs, right? So the biochemistry major is the one that I'll use as an example, has the core biochemistry core sequence. So a two-year biochemistry, two semester biochemistry sequence comes during the junior year. And typically students take the MCATs right after that. So the biochem major has this sort of 2-semester thing right before you need to demonstrate competency in all of that material. So some of the majors are structured so that they are providing some of that material right when you need it. That said, they're significantly more sequenced in where the courses come. So science pre-professional is a little more flexible in some ways. So if you want to study abroad, it's a lot easier to do that as science pre-professional than as a biochemistry major. I don't know, Mike, do you have any?
No, I think that's exactly right. That the science pre-professional majors are a little more flexible. I wouldn't say they're any easier. So hard science is a misnomer. It's all hard, or it's all it's as hard as you make it. So it's just that the sequencing is a little more flexible. There aren't necessarily as many requirements as you would have in a straight track science major, but you still have to you do probably more stuff even as a pre-professional than as a straight up science major. So there are trade-offs. So you need to kind of just talk to people and figure out what the best one is for you.
Oh, somebody's answering questions for us.
All right. Thank you, Peter.
Thank you, Peter.
Yeah, the biological sciences department, I think, is probably one of the most active in terms of engaging their undergraduates and actually running the department. They have this senior leadership committee that does a lot of great stuff in the department. It's viewed as quite a reward for engagement within the department, but they have a lot of impact on how the undergraduate curriculum is run. So it's really kind of a nice thing to do. So they're really engaged with the rest of the undergraduates. Favorite experience of the
I've got a lot.
Yeah, I know. It's hard to pick. It's really hard to pick.
Graduations are fun. I don't know, hearing from students after they come back. So I get a fair number of students who come back afterwards and say, I didn't like your class, your math methods class when I was taking it, but it's the most valuable thing I've ever done.
Yeah, and it's just you know, having your students who've worked with you just succeed, I think is great. You know, it's really fun to see them take flight and go on to great things. So I think that's the most rewarding.
Right. Actually, I think one of the favorite things that happened is I had two students in one of my physical chemistry classes who worked together on problem sets, and then they started dating, and then I got invited to their wedding 2 years later. So I think that's probably my favorite one is being a matchmaker for students in my class.
Nice.
That doesn't happen very often. So.
If you change your major, what are the chances of you graduating later? It really depends on how you do it. Yeah, in which direction you go. Is it really closely aligned to what you're doing? Have you taken a left turn? So it's hard to answer that question without the specifics. I will say though, that one of the strengths of the undergraduate program here is that we have advising and more advising. And so if you have any questions about what should I do with these courses, if I want to do this, that, or the other major, minor, can I have some advice here? How can I put this together? People like Professor Gezelter here and all the other advisors in the college know their way around the curriculum and will be able to help. As he said before, you know, you can design your own major, you can do various things, but there are a lot of people, there's a lot of support there for academic advising to help you through these things. So hopefully, if you were change majors, you won't graduate late because people will work with you to figure out how to make it all hang together.
So how often do teachers recommend you to internship programs directly? So this is teachers, so your professors will often write letters of recommendation for you. Sometimes we know about particular internship programs and we can say, hey, you know, Shania, I think you'd be a great applicant for this particular internship, but it's more common that students will find these opportunities on their own. We do have lots and lots of databases of you know, REU. I mean, you can search for REU programs and find all the current ones that are out there. But the advisors are really good at telling you about that. And then the individual faculty that you've had in your courses, one of the pieces of our job is to write letters of recommendation for students who've done, you know, well, for all students, but particularly for students who've done well in our courses. So, you know, actually, I think I just did 6 of them today for students who are applying to.
If you're reminding me that I have to write one.
Yeah. So that's, I've got a queue of them going. So every time I teach a course like freshman chemistry, I know that a year from that fall, I'm going to get a bunch of sophomores who are interested in doing summer research programs, and they're asking me for letters. And that's part of the job. That's what we're happy to do that, because usually the students we're asking us for are the ones who we connected really strongly with. So don't be shy about asking us for letters of recommendation. That's what we're here for. Lori pointed out to me something about the each of the advisors. So back to advising briefly. and graduating on time, so that the advisors meet with every student before registration every semester to talk about, are they on track? What's their plan for graduating on time? What courses do they still need to take? Things like that. So there's mechanisms in place to keep you sort of going and on time. Any other questions? Is it difficult to always get your first choice classes? No, not really, particularly if you're a science major. So I think people in the business school or computer science might have a much harder time than students in science do. So the registration works seniors first, then juniors and sophomores and freshmen. So it's sort of by seniority, and then you get a randomly timed window each year or each semester. So if you're early one semester, you get randomly assigned. You might be later the next semester. So not every class is always open, but science majors in general don't have a huge issue getting into particularly science classes. We tend to have capacity to do all of our courses in science.
Yeah, I mean, I've rarely heard of science students having trouble getting their required courses. That just basically doesn't happen.
Right.
If you want to get into some really popular theology course or something, then that might be more of an issue. But
yeah, the one exception is the fermentation and distillation class. There are 25 seats, and there were something like 75 people who wanted to take it. So that one, but we let the seniors in first. So.
Is it possible for undergrads to have training at different institutes and centers? Yeah, sure. I mean, again, it's your choice of what research problems that you're interested in, but faculty in all departments work in all these different centers. So if you find a faculty member whose research is interesting to you, yeah, you could be attached to one of those centers and do research there. Sure.
And some faculty are attached to multiple centers, so
right.
Be involved in energy research and drug discovery. Although I think there's only one faculty member who's both of those. Okay, we got about 2 more minutes. If there's any burning questions that you've got that we haven't answered, feel free to contact me by email. I'm going to put my email in the chat here. So actually, Katie asked me, what do you think is the coolest experiment you've ever done in a science department lab? So first off, I'm a theoretical chemist, so the answer is probably nothing. I do a lot of numerical experiments. We do computer simulations. So some of those are pretty interesting. The coolest demo I do in freshman chemistry is I do something called the self-carving pumpkin, which involves sort of a small explosion that is a lot of fun. So
very nice, very nice. If any of you ever built a cloud chamber, I think that is a really cool thing, which is basically supersaturated alcohol vapor. You basically think of a small aquarium. You put alcohol in the bottom with maybe a little felt around the edge so that it wicks the alcohol up a little bit. You apply that on a bed of dry ice. You get a supersaturated layer of vapor, and cosmic rays going through the vapor will leave little tracks. So you can actually see cosmic rays coming down from the atmosphere. That's pretty neat. It's very rudimentary, but you can see individual subatomic particles.
So one of the things we also do every fall is we make some liquid oxygen locally and then and pour it through the poles of a very strong magnet.
Oh, nice.
So liquid oxygen is actually paramagnetic, and so you can get the liquid suspended between two poles of a magnet. So we do that demo. That's a lot of fun. All right, so we've hit the 9:30 mark. Any unanswered questions? I put my email in the chat. I'm happy to talk to any of you. I'm looking forward to meeting you all in August, September, whenever we resume in the fall. And as I said, there's lots of things going on the rest of this week for people for various different science programs. Please, please, please go talk to them if you have any questions about specific sort of majors. It's a wonderful group of people who are there to answer your questions. Anything else?
Yeah, thanks for signing in. I'm glad. I hope we were able to give you answers to your questions, and we hope that we've at least generated some enthusiasm. So we hope to see you in the fall. Thank you.
Bye, everyone.